All right, we're going to look at 11.7, circles and circumference. We're going to look at some vocabulary that we need to know in dealing with circles. Probably the most common would be the segment that goes through the center, which would be a diameter. It goes from one point on the circle through the center to another point on the circle. All right, from the center out would be the radius. Now, radius is just half of a diameter, so just think about it. If you know what the diameter is, you could figure out the radius by dividing it by 2. If you knew what the radius was, then you could double it and get your diameter. So that is 2 of the common segments. This third one is not as common. It goes from a point on the circle through the circle to another point on the circle, and that is called a chord. Now, the diameter is the longest chord in a circle, so because it goes through the center, the widest part. So those are the 3 common segments that you would need to know from a circle. All right, we're going to look at circumference of a circle, which is the distance around a circle. Think about the distance around a circle. If you took a circle and cut it and opened it up, it would just be a length. So we're not talking area like we talked about yesterday. This is just talking about a length, and it will not be in square units. It will just be in regular units. Well, a really, really long time ago, we've talked about this when we were talking about Pi Day. There were mathematicians, they just sat around and all they had to do was measure circles. But they discovered this really important thing. If they took the circumference of any circle and divided it by its diameter, they always got this same amount, 3.1415926, and so on. So they thought that was so important, maybe that number really means something. So they actually labeled this number with a Greek letter and named it pi. Now we use pi as 3.14. We kind of shorten it so we don't use all those digits. Later on in math, you might use a calculator that uses a pi button, and that gives you more of an exact value for the problems that you're doing. All right. Also, if you're using fractions, your pi estimation, what you might use for pi is 22/7. So I would say that you're probably going to want to do that. Now, when we are looking at this, what they discovered, circumference divided by diameter is pi. They also discovered that if they could multiply both of these sides by diameter, these would cancel out, and they could figure out the circumference of any circle if they knew its diameter by taking it times pi. Now, sometimes you don't have the diameter, sometimes you have the radius. So if that's the case, you would take 2 times pi times the radius. That'd be equivalent to pi times the diameter. Okay, so now we're going to look at some examples here where we find circumference of some circles in different ways. The first one says that it has a radius, this one's got the diameter. This one's got the diameter of 12 inches. So what I'm going to have you do, just like yesterday, I want you to write the appropriate formula down first. So for circumference, pi times diameter. Now we're going to plug in the appropriate numbers. So for pi, we're going to put in 3.14. I guess I shouldn't be using blue because I'm going to have to write on that blue part. And the diameter is 12. Now I work the problem. So 3.14 times 12. And I get 37.68. My directions up here say round to the nearest tenth. So I'm going to say this is 37.7 inches long. That's the circumference of that circle, 37.7 inches. Do not square it. Circumference is not squared. All right, let's look at the next one. This time we're given a, looks like a radius, and it's a radius of 7.1 inches. So when I pick the formula out this time, I'm going to use the one for radius, 2 pi r. Plugging in the numbers, 2 times 3.14 times 7.1. All right, now it's just a matter of multiplying these numbers together. Well, 2 times 3.14, I know that's 6.28. I can do that one in my head. And I have to take that times 7.1. So 6.28 times 7.1, 44.588. Rounding to the nearest tenth, I would say 44.6 inches. All right, the next two figures are kind of interesting looking. We're really not going to do this one. We're going to do this one. It kind of looks like a track, but it's measured in centimeters, so it's a pretty small one. It looks like I've got the outsides of this rectangle is part of the perimeter, plus then two semicircles. So if I put the two semicircles together, I would have a full circle. So what I'm going to do to find this perimeter is I'm going to add, first of all, my 9 plus 9. So the two sides looks like it's going to give me 18. For the two semicircles or one full circle, I'm going to do circumference and use pi times diameter. That would give me the outsides of the full circle, and we're going to add that then to the 18. So I'm going to do circumference of 3.14 times 5. So if I take 3.14 times 5, I get 15.7. That is around the outside of that circle. So now I need to take 15.7 and add 18 to it. So when I add that together, I get 33.7. So my perimeter of this shape is 33.7 centimeters long. All right, now we have one word problem to finish off with, and it might take a lot of thinking, so we better put our thinking caps on here. It says a bike has a tire of radius 12. So I'm going to humor you by putting in this bike here, okay? What do you think of my bike? Okay, we won't even worry about the back part of that bike. But the bike has a radius of 12 inches right there. Okay, it has a radius of 12. It says if Bob needed to ride 1 mile, we better check that out. We better highlight some of this important stuff. If Bob needed to ride 1 mile, how many rotations does the wheel have to make? Wow, that's kind of a tough problem. I think what we're going to do first is find the circumference of the tire. So how far around does one rotation make? So circumference is 2 pi r. I'm using that one because they gave me the radius. 2 times 3.14 times 12. Okay, so when I go ahead and multiply all that together, I end up with 75.36. That is one rotation, but that is in inches too, by the way. All right, this poor guy's got to go a mile. So how many times around will that bike have to go? Well, let's talk about a mile. What do we know about a mile? I know that 1 mile is equal to 5,280 feet. Okay, that's still not going to help me completely, but I do know that there are 12 inches in 1 foot. So what I'm going to do is I'm going to take my mile as 5,280 feet and multiply that by 12. That's going to give me the number of inches in a mile. This is going to be a really big number. 5,280 times 12. So 63,360 inches in a mile. That's a lot. Okay, how many rotations around? Well, here's what we got to do. We're going to take my 63,360 and divide it by 75.36. We'll see how many times that poor tire has to go around. So 63,360 divided by 75.36. All right, a really long number. 840.6 7, 6, 4, 3, and da 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 da. How many rotations does that poor bicycle have to go? I'm going to say it has to go 841 rotations. We're just going to go ahead and say a full rotation to get that guy done. 841 rotations to get him down 1 mile. That was a lot of work. Let's go back and think about it. We did the circumference of the tire using 2 pi r. They gave us the radius. 1 rotation is the same as the circumference, 75.36 inches. I took my mile, changed it to 5,280 feet. I know there's 12 inches in a foot, so I took the 5,280 times 12, and I got this really big number, 63,360. I need to see how many times that tire has to go around to meet 63,360. So I divided by my 75.36. And I came up with this really long number, and I rounded to a nearest whole number, 841 rotations.